Well, I didn't put all four of the examples into the one video. In this video, I've included the two examples from the US. Due to the format of the data, the US examples were the best ones to slowly explain how we add up our accumulated heat to estimate how long it will take our crops to mature, thereby estimating our harvest date or our planting date if we're expecting a fall crop. You can also analyze the best time to plant for the fastest growth. For the US examples, we'll go back to this website, pnwpest.org, and we'll go down, since we're doing cool season crops, to the section that says degree day maps created daily using a 41 degree Fahrenheit lower threshold, and we'll click on the Google Maps interface. And for the first example, I'm going to select Michigan. When we zoom in, the overlay will disappear and we can find our border between Michigan and Indiana, and here it is right here. So I'll zoom back out a little bit. I'm going to take an area close to the lake. Being surrounded by the Great Lakes, the climate is somewhat moderated, similar to a marine climate. And so here is South Haven, and if I want, I can zoom right in. Let's say if I lived right here in this house at the turn of Cider Crescent, I can click on that house. It will give me my data up here in the left hand corner, and the station, it says SVNM4. Now if I were to go over and click on a house by Michigan Avenue here, the station is still SVNM4. So on both houses you get the same station. That is because it's coming from the nearest station. So zooming in and clicking right on your property, getting the data this way, won't help you any at all. You just need to click on close to the general area and it'll give you the data from your nearest station. So we'll click on the station number now, and you end up with this table. So let's look at this now. We have our month and day, our maximum temperature and minimum temperature, our precipitation, our daily degree units at base 41, and accumulated degree units at base 41. Now I said I'd plant the carrots a week before the last frost. So we'll look at the minimum temperature column here, and we'll scroll down and find where the last date is that has a below 32 degree Fahrenheit temperature. And here we'll find that that date is right there on April the 18th. I don't know what the expected last date is here, so I just go by the data that we've got for this last year. We'll go a week before that, which will be April the 11th, and say that's our date that we're going to plant our carrots. Now going down 65 days, you get June the 15th. If we look at our accumulated degree day column, we have accumulated up to April the 11th 81.8 GDUs. And in our last video we calculated that the carrot needed 1,560 to go from seed to maturity. So we will add that 81.8. You'll add 1560 onto that, and we get 1641.8. That's the total accumulation the area will have by the time we get the amount of heat accumulated that we need. So we'll scroll down until in that column we find it is equal to or greater than the 1641, and we'll find that is on July the 1st. So now we've already gone from June 15th, we've gone 16 days past the 65-day mark. We're up to 81 days. But if we look now at the daily accumulation of GDUs, work our way down, we have 13, 21, 23. At May the 24th, we have 27.8 GDUs. Now we calculated in the last video that a carrot can only make use of 24. So while we have it accumulating in total, it is not available for use to the plant. The next day we have 32, we have 27. Now this 34, we also calculated that the maximum tolerable for a carrot plant was 34. This is 34.5, so we've gone over 38.4. Now this is why I selected this area though. In a marine type climate, you'll have it go up like this and then you're down again underneath. These here 20, 26, 21. And then some go up above what the carrot can use again. There is a couple more that is above the tolerable, but not very many. And we go all the way to July the 1st, just 39.55. Now all of these that's above 24 will only be used by the carrot 24 GDUs. So we're not going to get to that 1651 or 1560 accumulated by July the 1st. So we're going to start at April the 11th and add in our calculator 3.96 plus on May the 12th it'll be 6.68 plus on May the 13th 8.5 and so on until we get down to one of those that's above 24. So that was on May the May the 24th. So on May the 24th, where it says 27.8, I will add in 24. And the 32.45 on the 25th, I will add in 24. And so on until I add up to the 1560 needed for the carrot. I will do that in high speed so I don't bore you to death. Now, adding up all the day by day, the usable heat for a carrot plant, we get all the way to July the 10th, which is 90 days past planting date. That is concerning heat alone. Assuming you don't have any other limiting factors, it will take you a minimum of 90 days to grow your carrot when you planted a week before the last frost in this location. The other limiting factors could be soil fertility, moisture, pest pressure, etc. So the chances that you'll get it grown in 90 days are slim. Now, let's go down and we talk about having a fall crop. For a fall crop, I said I leave them in the ground for 2, 3, 4 frost. We'll go back to the minimum temperature column again, and we'll find where our first frost is, which looks like this year it was on the October the 24th. Then we have the 25th, and we have again on November the 9th and 10th. So we're taking up our carrots on November the 10th. On November the 10th, the accumulated heat for the year was 4,688.1 GDUs. So, 4,688.1, subtract our 1560 equals 3,128.1. But first, let's go back 65 days, which will take us to September the 6th. On September the 6th, we have 3,758. So we already know that we're short on the number of days. To get back to what we need, 3,128, we need to go back another 23 days to August the 16th. So once again, we're up to 98 days, considering just the straight reading from the heat accumulation. But we'll go back and we'll do this again from November the 10th and do our calculation of the actual heat availability, and we'll find out how many days it takes for the carrot to accumulate its 1560 GDUs. Now, taking into account just adding up the usable heat for a carrot plant, it takes us back to August the 9th, which from November the 10th is 93 days. So, what the hell you're saying? What do they say? 65 days. Well, we could probably do it in Michigan, so let's go back and scroll up to where the days become the optimum temperature for growing carrots. The temperature is a little bit up and down, but if we look at the daily GDU column, then we come to find that after about May the 24th, I guess, most of them are in the optimum temperature range. So now we're straddling the warmest part of the season for growing our carrots. We'll plant on May the 24th, at which point we have 546.4 GDUs already accumulated. 65 days down from that, July the 28th, and there's 2,400 and 82.5 GDUs accumulated. Now, 2,482.5 minus the 546.4, and we get a greater amount of heat accumulation than the carrot needs. We have 1936, the carrot only needs 1560. So let's go back now to May the 24th and start adding up the usable heat. So adding up the usable heat, we get July the 29th, which is 66 days. So straddling the warm part of the season in this location, you can theoretically get a 65-day carrot to mature in 65 days, providing the other factors don't create a limiting issue. In this area, there are some days that go beyond the tolerable limit, but there's not many and they don't go very far, so that's why I selected that location. Now we'll select somewhere that has a true warm season with straddled by two cool seasons, spring and fall. Let's zoom in on central US here. So we're in the Cayenne Bottoms Refuge, so close to that. Okay, so on the northwest side, you're going off station D8749. So the first thing I'm going to point out with this one is that if we look at our daily GDU column and we get down to about May the 22nd, from that point the heat accumulation is above the tolerable of 34 all the way down to, except for a couple of cool periods drifting by, that heat remains around until September the 19th. So for that full period, May the 22nd to September the 19th is too hot for carrots. So let's take May the 22nd and go back 65 days. Our first thing to make note of is on May the 22nd we have 1,516 growing degree units, which right away says that we may not be able to get our carrots mature before that date. For 65 days we're back to March the 18th, and our last frost date is way up in April the 10th. There was even one on April the 15th. So if you're planting carrots now on April the 1st, let's say, 65 days is going to take you to June the 4th, which may not be too bad. There we have our 1985 minus the what was already accumulated, 503, equals, and we're down to 1,482. So with just heat accumulation alone, we're going to go a couple of days beyond that. Since most of those days are above the 24, I'm going to estimate, and we're going to go April the 1st is 503, and up to our hot days on May the 22nd, we have 1516 minus 503 equals 1013. So 1560 minus 1013, we need another 547 GDUs. Divide that by 24, we've got 22, so 23 days, which will take us to June the 14th. So it gives us a total of 75 days. If you do the same in the fall, we're going down to September the 20th. So on September the 23rd, we have 6126.4. And then we'll look for our frost dates, which is November the 8th. And there's a few frost dates right in a row there, so it looks like it gets cold suddenly there as well. So we'll pull them up. We'll say try to get them mature by September the 8th. In which case we have 6824.3 minus 6126.4 equals, we need another 697.9. So divide that by 24. We need another 29 days before our September the 22nd. 65 days back from November the 8th would give you September the 4th. But we need 30 days beyond our September the 21st, which would bring us back to August the 22nd, giving you a total of 93 days for your fall crop, and you had to plant it by August the 22nd. So that was 2 examples from the US. Hopefully it was clear. If you didn't quite understand, please leave me a comment and I'll be happy to further explain it, most likely in another video. So I hope you found it interesting and informative. Please hit the like if you did. Make sure you comment, like, and share. This is Jocelyn from Ecocentric Homestead, hoping you have a great 2019.